This video is about continuously compounded interest. So if this is the interest formula, this corresponds to 100% interest, but this makes sense for anything. What would happen if n was 1? Notice that corresponds to being compounded annually if you divide by 1 there. Notice that this is 1 plus 1 to the 1, that's 2. If you plug in a 2 there, it's 2.25. If you compound 5 times a year, it's 2.48832. And you can see this number grows just a little bit, all the way up until at 1,000, it's 2.71692. And you might ask this question, what happens if you're constantly getting interest on your interest? So something like maybe the stock market, where as soon as the value of your money changes, everybody's calculating based on that new value. Well, this gives rise to a very important number in mathematics. It's called E, or Euler's number. That's 2.7182818. And that number is the number that is used in the continuously compounded interest formula. It's similar to the other formula. The amount is calculated in terms of the principal, but now we have e to the RT. Both the rate and the time are in the exponent, and this e is not a variable. It's a constant. It's a number. It happens to be an irrational number. I have this approximately equal to because it goes on forever, but this is probably close enough, although typically I use my calculator, which actually goes out to 10 or 12 digits for accuracy. Okay, let's just do an example problem of something that looks like this. Let's imagine that I start with $5,000 and get 10.5% interest compounded continuously for 10 years. Now, the reason I say 10.5% interest, that's the long-term average of the stock market over the last 80 years or so. What amount will I end up with? Well, using this, the amount I'll end up with is the principal times e to the 0.105 times 10. Now, that's something you'll want to plug very carefully into your calculator. And you get $14,288.26. Hope that helps.